So this lesson is not just for the people who have Geometry Unit 5, although this is support for those students. But I assure all of you, no matter what you teach, you're going to end up working with students on equations of the line, x-intercepts, y-intercepts. I think it's really important to have students do something like this, right? Where points are labeled along the x and y axis, and they have to write the coordinates of the points. Again, this makes it more concrete and a little bit less abstract, right? And so as they're labeling points along the x-axis, right, they're noticing that y is always 0. And as they are labeling points along the y-axis, right, they are noticing that the x value is always 0. Okay, so I think that that's an important thing to do for teaching students about x and y intercepts. Also, when you go to graph these either horizontal or vertical lines, for example, since I've got room here, I'll do this one, y equals 2. But ask the students then to label points along this line. This is the point 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, right? So then you're saying to the students, what do you notice at every single point? What do we notice, right? That y is always 2. Kirk does hint at that on his handout. I might recommend that it be done a little bit more explicitly, right? I think he has them labeled 2 points and asks them to draw conclusions. I would have them label more like 4 or 5 points and ask them to draw conclusions. So looking at some of Kirk's stuff, and his geometry stuff is a lot better than, for example, his stat stuff. Okay, so Kirk absolutely puts out some good stuff. There's a reason he's become a millionaire off of his eMath instruction. And he does a better job in the geometry, I think, trying to get students to draw their own conclusions. That's what he's trying to do here with these perpendicular lines. And he's saying, you know, here's 2 perpendicular lines, find the slopes by counting the boxes and list as many observations as you can. I would actually do a little bit more in the way of reasoning, right? And this is where you can really get the students reasoning. All right, I would draw 2 lines, one with positive slope, one with negative slope. All right, so they should know how to identify positive versus negative slope. And I would say to students, if I were to draw a line perpendicular, what kind of slope, positive or negative, would it have? Right, so is there a relationship between these signs for the lines that are perpendicular? And they should be able to conclude that they always have opposite slope. Okay, and I would ask them, is that always true? Is it possible to have perpendicular lines that have the same sign, that either have both positive slope or both negative slope, right? Is that possible? Why not? Students will probably, I'm trying to draw a perfect horizontal line. They'll probably draw something like this, which actually these lines are a little bit later in the lesson, right? The vertical and horizontal lines. But just because they come later in the lesson doesn't mean we can't talk about them if they were to naturally arise in our discussion. And then another thing I would ask students is we'd say, okay, we've agreed that, you know, if this has a slope of positive 2, the slope of the perpendicular line has to be negative something, right? So do we think, would it be like the same slope, only negative, right? Or would there be no relationship between the numbers? Or do you think there'd be a relationship between the numbers? Like if this had a slope of 3/5, right? And this is the perpendicular line. Do you think there's no relationship at all between these numbers? Do you think it's the same, only negative? Or do you think there's some sort of relationship? Okay, and do that first. Let them make predictions. They're reasoning here. And then they'll be more curious to go to this page and actually see what is the relationship between the numbers. So I think Kirk's stuff is pretty good here, but I think you could take it one step further to get students doing a little bit of reasoning. Now, with the distance formula, you should be really building the connection between the distance formula and the Pythagorean theorem. One thing that I suggest you do while you're finishing up Pythagorean theorem is you should have students solve for x and have them recognize that the hypotenuse, right, is simply, because they'll say x squared equals 2 squared plus 3 squared, have them recognize that the hypotenuse is the square root of the leg squared. Okay, so that they know that C, now of course, they're still young and they still get a little bit upset if you do too many letters and not enough numbers, right? But this would be a formula that C, the hypotenuse, is equal to the square root of the leg squared. That's going to help them start to recognize when we use the distance formula that you're simply finding the hypotenuse of a right triangle. All right, so when we're doing this stuff, right, we're drawing the right triangle in. And, you know, students might be counting boxes to find out how long this leg is and how long this leg is. And that's where you should be saying to the students, could I say I didn't give you boxes to count? What would you be doing? What would you be doing with those points? And then give them something where you take away the grid and say, okay, I'm going to actually take the grid away and tell you that these are the coordinates. Okay, so say 1, 5, and I don't know, 10, 12, right? Something like that. I took the grid away. You're not allowed to count, right? How do you know how long this horizontal segment is? How do you know how long this vertical segment is? And take your time building the formula. Kirk does help build the formula, but I think he gets a little bit too abstract, a little bit too quickly. Okay, like right here, he comes here. Remember, for us, we're okay going into letters and this abstraction, right? Our students, remember John talking about that in some of his lessons where he'd say, okay, I know I'm getting too many letters in here. I know that's going to upset people. You like numbers, not letters. Because this, I think he just gets a little bit too abstract, a little bit too soon. All right, because what he's trying to do is show students that this segment is this, right? But they need a few more examples, I think, before they're ready for this. Okay, so this should be built up nice and slowly, I think. And then this should be connected to the formula that you worked on, that the hypotenuse is equal to the square root of the legs squared. Okay, so this is some support for you guys that are doing the geometry segment, but all of you, right, no matter what you teach, you're most likely going to do equations of the lines, right, distance formula. This is all stuff that shows up over and over again in multiple courses. So this was good for all of you to see some of this and to talk about how we build up slowly. We don't want to jump too quickly to the abstract, right? We've got to stay in the concrete, let our students get comfortable with concrete examples, then move into the abstract. So thanks for watching.